All right, hello everybody. Hopefully you are watching this Tuesday evening before your class on Wednesday. Um, so just to I will let you know where we're at in the notes. This top part right here is all about the exponential functions. It's on the page in your notes. It starts off on the very top. It says exponential functions, then it talks about your a and your b and your x, and then these three graphs are on there, and then you have like questions A, B, and C to fill out for each one of the graphs. I'm not going to worry about filling out the questions. You can answer those on your own, or at least you should be. This is just a review of what exponential functions look like, and then I'm going to compare them to logarithm functions. So with exponential functions, they have this curve up, and usually you have an asymptote at the horizontal axis, and you can either curve up like this or sometimes you'll curve down. So if you are increasing exponentially, you'll have an exponential growth, and it'll start small and go up very quickly. If you are decreasing, you'll have an exponential decay like these two examples, and you'll start really high and then come down. Okay. Now, how do those compare to logarithm functions? Well, let me just show you the graphs. Okay. So these are the page in your notes. Let's see. Let me find them. Oh, very next page. All right. So these are the equations, and then it says sketch the graph. Well, these are the graphs here for you. So go ahead and sketch those. I am going to let you answer the questions that are on that page. One of them was like, which graph has the greatest vertical stretch and all that fun stuff. I'll let you answer those. You should be able to answer it fairly easily. So right now I just want to compare your graphs. So with exponential formulas, you're going up like this, but with logarithms, you have the same basic curve, but you have an asymptote you have a vertical asymptote at your y-axis, and then you have this type of curve. So it's just almost like a inverse curve, basically. And you'll see that you can have lots of different types of logarithms. We'll cover in the next, like for the rest of this week, really, we will be covering all types of different logarithms and how to simplify them, like when you have this type of situation. Okay, so those are what the graphs look like. Hopefully you have them sketched in your notes by now. Let's go ahead and look at the relationship between your exponential function that is here and your logarithm function that's here. Okay, notice that they actually are reflections of each other over the line y equals x, and this is because they are inverses of each other. On the worksheet tomorrow, you'll need to know what that relationship is, and they're just inverses of each other. We talked about inverses like at the very beginning of the school year, like way back in August. So if you've forgotten what inverses are, basically they are reflections across the line y equals x. All right, so you have this relationship there. So logarithms and exponential functions are very similar to each other. They also have the same kind of properties. We'll get into that in a minute. But what we are going to be doing in Wednesday in class is we will be converting from an exponential function that looks like this to a logarithm function that looks like that. Okay, and I will tell you, most of my math career, even in college, when I was in college and high school, I hated this unit because I would always forget, okay, where does the y go? Where does the x go? What happens to the extra number? And I would always mess them up, and it was just such a pain. And then I was actually teaching a couple years ago, and somebody said, Miss Pye, this is how you keep it straight, and this is how you remember. So your b value here, just tell yourself that number is your base, okay? That's always your base. So always call it your base number. It doesn't matter if it's a 2 or 3 or of a 5 million. That's your base, okay? When you have a log, it's still your base number. When you are putting logs in your calculator, this is called your base number. So if you keep that as the base, then it's always going to be the base, whether it's exponent or logarithm, okay? And then all you do is switch the place of the x and the y. If you notice, that's all they did. So for logarithms, you add log to the base, and switch the x and y around. Okay, so if you have exponents functions and you want to convert it to a logarithm function, what do? You add the log to the base and switch the x and y. Okay, so that sounds really simple, but I'm telling you, you will get confused. Okay, where does the x go? Where does the y go? Especially when you, instead of having an x and y, they put numbers in here. And tomorrow, in fact, if you look right here, guess what? We got rid of the x and the y and the b, and we put numbers in there. Okay, so remember, this is your base number. Always start there. So if you want to convert it to a log, you add a log to your base number. So 5 is my base number, and then I'm switching the location of my x and my y. So it's going to be log base 5 of 125, and that's going to equal 3. Okay, so I just switched places, and added a log. All right, so now let's convert from a logarithm to an exponential function. Well, for a logarithm, you get rid of the word log. Your 2 is still your base number, and then voila, all you have to do is switch those places. So it's 2 to the 6th power equals 64. And if you want to check, it actually does equal 64. So if you have a calculator handy, you could do that, 2 to the 6th power. All right, so essentially that's what we're going to be doing most of class tomorrow. We're also going to look at some of your properties that logarithms have. Okay, this is just a couple of them. You know what? I don't think I told you. These are going to be in your homework problems or your worksheet tomorrow. They're not in your notes. If you want to sketch them, there's a lot of margins. The page that has what graphs? Yeah, so the page that has these graphs on it, there's like this huge margin on the right. Go ahead and plug that stuff in. And I don't think I put this in your notes. Again, if you want to include it in the notes, go ahead and draw it in that margin that you have there. And this is going to be on the worksheet tomorrow. I'm not going to give you the information in class tomorrow. I will just say, hey, you need to answer this. Okay? So if you have this written down in your notes right now, then it'll be super easy tomorrow. So I'll have like 1, 2, 3, 4. I just gave you 4 problems on your worksheet in class tomorrow. All right, so let's go back and look at these properties. Now, these properties are in your notes, but I think they're a couple pages later. We will get to the natural logs probably on Thursday, possibly Friday. It depends on how we do with this. So just a couple things you need to know. If your number that's here is 1, it'll always equal 0. It doesn't matter what your base number is. If these two numbers are the same, you get 1. If you have these two numbers that are the same and this number has an exponent, these two actually cancel each other out, and it's just x. And then if you have a base number with a log of base b and an x, again, those cancel each other out. You'll think that that's pretty easy and you'll never see a problem like that, but homework worksheets, your professors in college, they love to give you situations like this where they cancel things out. And so make sure you understand those properties. And I do not expect you to memorize all this, but do be familiar with it and how you can simplify stuff. So on Thursday and Friday, we are going to be simplifying some of our logs, so make sure you know those properties. And then here's a couple more, and these are very similar to the properties you have with exponents. So when you're timesing here, you can break that up, you can split it up by adding. If you're dividing here, you can split it up by subtracting. And then if you have a log, a base, some number, any number, and then you have another number here and it's raised to the exponent, well, you can actually move that exponent out front and just multiply it. So like this would be p times log all this, okay? And so that's what they're showing you here. Again, these notes are further into your unit, into the notebook or the packet of notes. So you don't need to copy these down, but I do need you to be familiar with them. We will be spending like the whole rest of this week just looking at logarithm functions, simplifying, multiplying, dividing, all sorts of craziness. All right. So hopefully you get all this stuff down and you bring your notes to class on Wednesday, because if you don't, you get to do all the work by yourself instead of working with a partner. All right, so I will talk to you later. Bye.